Since this begins our polynomial arithmetic section, we're going to have to go over the parts of a polynomial. So this right here written on your paper, on your notes, 8x squared minus 3x plus 2, the stuff written in black, that's a polynomial. There are many terms. In fact, there are 3 terms. You have 1 term, 2 terms, 3 terms. Do you see how there's 3 different things all separated by either plus or minus signs? Yeah. That's called a polynomial. In fact, this one is specifically called a trinomial. Why do you think it's called a trinomial? Because there's 3 terms. Okay, if it has 1 term, it's called a monomial. Mono means 1. If it's a binomial, how many terms are in it? 2. If it's a trinomial, there are 3. There's not another specific name for 4. After that, we just call them all polynomials because we just got lazy and didn't name the rest of them. So you have monomial, binomial, trinomial, and polynomials. Okay? So for polynomial arithmetic, we have to know the parts of a specific term. The very beginning term number is called the leading coefficient. So this number right here, it's the one that's connected to the highest degree. What's called the leading degree, or the highest degree. And then the very last thing, do you see how there's no letter attached to the very last thing? That's going to happen for most of these problems. It's called the constant term because it's just a regular number. Those are the parts of a polynomial. This order that it's written in is called standard form. I want everybody to circle those words right there, standard form. What do you notice about the order in which these are written so that it's called standard form? What's the power of the first term? What's the power of the second term? What's the power of the last term? There's not 1, which means it would be 0 because it's not there. So it goes in decreasing order. We start with the biggest power, then the next biggest power, then on and on and on until we get to the constant. That's standard form, and I'm going to ask that you write your answers in standard form always. So put them in the correct order. Now, first order of business is to be able to add and subtract polynomials. Guys, this is super easy. Adding polynomials together is no more complicated than combining like terms, which means adding together the things that have the same variable and power. We're going to add the coefficients and leave the exponents alone for terms that are alike. Here's how I would like for you to set up your problems. When we have an addition problem, like example 1 here, all I need you to do is line up the like terms. So this term right here, x squared, I need to write it underneath one of the terms in the first trinomial. Do I write it here underneath the first term, under the second term, or under the third term? First term. Okay, I'm just going to write it down. This is x squared. Fantastic. The next term in the second polynomial is negative 8x. Where should I write that down? Under the negative 4x. Okay, great. And then I have a positive 1. Where should I write the positive 1 down? Underneath the 2 because it's its like term. It doesn't have a variable. The reason I'm doing that is because now I can just add like you did in elementary school. The first thing is 3x squared plus 1x squared. That's 4x squareds. And then I have negative 4x plus negative 8x. Negative 4 plus negative 8 is negative 12 x's. 2 plus 1, my constants, is 3. That's it. I've simplified it. But here's the thing. Polynomial arithmetic needs to be your favorite subject in this class. It's honestly mine just because I actually really like polynomial arithmetic. But it needs to be your favorite because every single answer is an equivalent expression. Say that with me. Equivalent expression. What does the word equivalent mean?
Same.
The same. So if we were to graph these expressions, both the question and the answer, what would the graph look like?
A graph.
Well, yes, it would look like a graph. But you just told me equivalent means the what?
The same.
So the graphs would look what?
The same.
Oh, let's double check. I'm never going to tell you if you're right or wrong for the next few days. You're going to tell yourself if you're right or wrong.
Wow.
Because you can check all of your work. Let me show you how this works in Desmos. Okay, I want you guys to try number 2, example 2. Don't ask me if it's correct. You should be able to answer that question for yourself. You line up all the like variables. They may not be in order. And then you're going to add them.
So it don't matter if the things are in order.
Does it? You just have to make sure you line up the correct ones. So like make sure the squareds go underneath the squareds and the x's go underneath the x's and then the regular numbers under the regular numbers. Does that make sense? Okay, great. Okay, so did everyone get something like this? Okay, that is absolutely correct. However, you won't see answer choices written in this form. I made a big stink a second ago about what something called standard form. What should always go first in standard form? No. No. The power of. Look at the top of your paper. In standard form, the black equation written there. What power goes first? The biggest power. So what's the biggest power here? 11. No, not coefficient. Power. Power's the little numbers. 2. So we need to have this negative 5r squared go first. Then I can have the r to the first power. Then I can have my regular number. This is the same exact thing. It is an equivalent expression. It is just written in standard form, and that's what I prefer. That's what mathematicians prefer. We always write our answers in standard form.
So it goes like greatest to least?
Greatest to least power, absolutely. It's greatest power to least power. That's absolutely correct. Greatest to least power. Did you check it in Desmos, by the way?
Yep.
Yeah, remember you change all of the letters to X because Desmos only thinks in X's and Y's, not R's. But R's have to be on your paper because that's the letter that they gave us. Can we move on to subtracting? It's not that bad. Here's the rules for subtracting. Subtracting polynomials introduces one extra step where you must be careful. If there is a minus sign before a group of parentheses, you have to change the sign of every single thing in that parentheses. Notice how before I distributed the negative 1, this 2x was positive, and now it's a negative 2x. You see how this was negative 9, and now it's positive 9? We changed the sign of everything when we're subtracting. So when I go down to this problem, I'm going to write everything underneath its same thing so I can combine like terms. But instead of writing the exact same thing that I see in this parentheses, because I'm subtracting, I'm going to write the opposite.
So it's going to be like positive 2 to the x to the power 2?
That is correct. So underneath the 5x squared, I'm going to write positive 2x squared. Underneath the negative 8x, what am I going to write? Negative 5x. Change the sign of everything. Underneath that positive 12, what am I going to write? What?
10.
Negative 10. Okay, now I can just do my problem like normal. Subtracting is just adding the opposite. So if I write down all of the opposites, I just have an addition problem. Basically, what we've done is we took this entire thing and we wrote it down as its opposite.
So when we're adding like negative,
So it's not adding, it's
negative 5, is
it's
it
not
going to be a
subtracting, it's
positive
adding.
or a negative?
Are you saying like the next step? Well, you already took, look at my air quotes here, took care of the subtraction by writing down the opposite. You have distributed negative 1. So now it's just an addition problem, regular addition like we just did. So my next step is just going to be 5x squared plus 2x squared, which is 7x squareds. Negative 8 plus negative 5, which is negative 13 x's. And then 12 plus negative 10, which is positive 2. But remember, we can add, because this little purple, when we wrote it down the opposites, that's the subtracting part. Subtracting is just adding the opposite sign. So we wrote down the opposite sign, now we can just add. Okay, your turn. You've got example, what number are we on? 4. That one's yours. Yes, sir. Okay, I'm going to draw your attention to something on this problem that I've seen a lot. Right now, I'm going to cover up the beginning of this problem because I think we're super confused on the same part right here. Okay, hold up. Don't do this. Just listen. What's the power of the first term right there? The coefficient is 6. Is it positive or negative? Positive. What's the sign of the second term? Negative. Okay, so if I'm subtracting these things, I have to change both signs. You just told me that the 6m was positive and the 8m squared was negative. So when I write them down underneath, the 6m was positive now needs to be negative. The negative 8m squared was negative, now needs to be positive. Now I can add. So I'm going to get correct negative 3m, positive 4m squared, and then this plus 2 that didn't add with anything. It just gets to drop down. So what I'm noticing here, that we messed up on changing the positives and negatives whenever we're subtracting. So make that a point that you're looking at there. And then additionally, I just see us adding wrong. Guys, don't let arithmetic be the reason you miss this problem. Use a calculator, please. Negative 4 plus 8 is not 12. I saw that in 4 people's papers. Oh, you're right. It's not even written in standard form. Can I fix that?
Yes.
What's the standard form version of this?
4m to the power 2. Well, yeah, and plus 2. It's minus 3m. Oh, yeah. And plus 2.
Very good. That would be what you see in answer choices. The first one, the one we got right out of the problem, is not incorrect. It's still equivalent. It's just not in standard form, which is what we like to write them in, is standard form. All right, we've got one more example to look at before I'm going to let you practice on your own. So let's look at example 5 altogether. Whoa, how many things am I adding together here?
2.
Okay, so here's one term, and then the next thing is in parentheses. Whoa. And then the next thing is by itself, and then the next thing is, in parentheses again. So we've got a lot of things going on here. I'm still just going to do my best to line them all up with the very first thing. The blue 8x minus 10x squared. Am I adding or subtracting that parentheses? Wait, in front of it, what do you see? I'm adding. So when I'm adding, do I need to change the signs? No. Okay, so when I write down everything from the blue parentheses, they're going to be the same sign, which means I'm going to have negative 10x squared. Look, I lined it up with the x squared. And then a positive 8x. And I took care of that. The 8x doesn't actually line up with anything yet because my very first term only has an x squared in it. Correct? Okay. Then the green 4. Can it line up with anything I currently have written on my problem?
Yeah.
Which one?
The 4 on the parentheses.
Oh, well, eventually, yes, but in the stuff I've written down, it doesn't line up with x squared or x, so I'm just going to put plus 4 right there. Okay, taking care of the plus 4. Now this purple 2x plus 4, am I adding or subtracting it?
Subtracting.
Okay, so when I write down these purple numbers, am I going to write down exactly what I see or the opposite?
Opposite.
Okay, great. Where should I line up the 2x?
The bottom right.
Underneath the 8x, but I'm going to make sure it's the opposite because we're subtracting that one. And where should I line up this plus 4? With the 4, but do I put plus 4? Negative 4 because it's the opposite. Okay, I have a really long problem here. No big deal. Add straight down. You've lined up all of the like terms. 3x squared plus negative 10x squared is negative 7x squared. I did this. Do y'all see that? I added those two things. And then I'm going to add straight down 8x plus negative 2x, that's positive 6x. I added these two. Those are my like terms. Then I have 4 plus negative 4. What is 4 plus negative 4? 0. So I can put plus 0 at the end. But when you write this answer, if you saw it on a test, like for me, if you wrote plus 0 at the end, I'm giving you full credit because that's technically correct. But in an answer choice, it's only going to say this. Do y'all see that those are exactly the same thing? Yeah, because if you add 0 to something, it's the same thing. But luckily, again, this problem is an equivalent expression. So you can totally put the question, all of this, I know it's kind of long, and your answer into Desmos and double check that it has the same graph. It'll have the same graph, same table, same input, same outputs.
Will we put it in Desmos? Can we put the 0?
You can, yes.
Okay.
That was a good question. She asked if you are putting into Desmos, you can put the plus 0. Yes. Okay, so here's what we're going to do. We're going to practice a little bit. You have a sheet that you also picked up when you walked in titled, Who's That Pokemon? All right, we have two methods that I'm going to teach you how to multiply. I prefer for you to use the distribution method, But I'm also going to show you what's called the box method or the Punnett square method. How many of you are in biology? How many of you in biology have done Punnett squares already, right?
Oh my god, I hate it.
Okay, great. We're going to make that math. But first things first, I'm going to show you what's called the double distribution method. If you Google this online, sometimes it's called the FOIL method. Oop, my pen didn't write. Sometimes it's called the FOIL, F-O-I-L. It's called the FOIL method. Doesn't always work with the acronym FOIL, which is technically why it's called double distribution. But what's going to happen, it's like super distribution. Do you remember how when we did regular distribution with a number, it'd be like 5 plus 2? What would you do with this 5?
You would multiply it into everything inside the
Great, and I would get like 5x and 10. I'd multiply it to everything. What's going to happen is we're going to do that twice.
Why?
Because it's called double distribution. What's happening now is the first thing in front of my parentheses is no longer a number. I'm going to have to multiply every single term to every single term. It's double and or triple distribution, which is wild. But let me show you an example because it's not that bad, especially when you remember how to set them all up. So double distribution method. First thing we're going to do is draw an arrow from the first term to the first term. I'm going to multiply those first. 3x times 5x is 15x squared. Why is it x squared?
Because of multiplying the five.
What's x times x?
X to the power of 2.
X to the power of 2. So 3x times 5x is 15x squared. The number should get bigger. The power should get bigger by 1. So just know it goes up by 1. Then I'm going to do this again. I'm going to do 3x times 4. Well, 3x times 4, that's just 12x's. Did you follow that? That's one distribution, but this is called double distribution. So I'm going to have to do it again, but this time I'm going to use this negative 2. What's negative 2 times 5x? But I'm going to line it up with its like term, because we just learned how to add polynomials, and when we combine like terms, we're going to need to have them all lined up. So negative 2 times 4x, when I go back to distribute one more time, that's negative 8. And look, it's now it's just an adding problem. We just did a million of these. That was an exaggeration. We did like 10. Then we'd get 15x squared, positive 2x, and a negative 8. Did you follow?
Yes.
You know what's nice about these problems, and I said this at the beginning of class, you can still check your work in Desmos. So everybody right now, I want you to go to Desmos, and I want you to type in the entire question. Notice, there's nothing in between these two parentheses. They're just smushed next to each other, so make sure you do that. And then I want you to type in your answer choice. And if they're equivalent, that means that they're the same. So we can always check our work to make sure we got this right. So you always check your work. I'm going to show you this same question using a different method that you may prefer. I prefer this method, and I would love for us all to get here, but I understand that sometimes people need more structure than that. So we're going to use what's called the box method. This is the same problem, so we should end up with the same answer. How many terms are in the first parenthesis? 2. How many terms are in the second parenthesis? 2. So I'm going to set up a box that is 2 by 2. And I'm going to list the first parentheses on the top and the second parentheses on the side. For those of you that did Punnett squares in biology, which I know is not everybody, when I was crossing my genotypes, am I using the correct language? Is that correct? The alleles of the gene that I'm, nope, that's not the right words. What words should I be using?
It's
Isn't it the alleles? Miss Jackson? Alleles. I was like, Miss Jackson's a science person. When I'm crossing the alleles, I would have just written down the letters from the column and the row, correct? That's the same sort of thing for math, except when I write these down next to each other, I'm multiplying. What's 3x times 5x? 15x to the power of The power should get bigger, so power of 2. In the next row, I'm doing negative 2 times 5x. What's negative 2 times 5x? Negative 10x. What's 4 times 3x? We're just doing the next row and column. 12x. And then the very last box, what would I be multiplying to put in that last box? 4 and negative 2, which 4 times negative 2 is negative 8. What do you notice about this part of my box?
They're the same.
They're the same. What do you mean by they're the same?
They're the same
Variable. They are like terms. What do we do with like terms? We add them. What's 12 plus negative 10? 2. So my final answer would be the 15x squared I get from the top, that 2x you just told me, and the negative 8 from the bottom box. This is the same answer we just got and checked using the double distribution method. You get to decide which method you use when you multiply polynomials together. Again, I prefer double distribution. It takes less paper, and it helps you if you're going to advanced math, because that's how the advanced math teachers will want to teach it. But if you need the help of the box, you use the Punnett square method. So I'm going to pull your attention back. Go back to your notes for a second. We're going to do another example of multiplying just because I think it'll be helpful. But you guys get to... Whoa, I almost just tripped. Did y'all see that?
No.
I'm going to let y'all... Thank you for being polite. I'm going to let y'all choose. Do y'all want me to do the one with the fractions or the one with multiple, or with a trinomial?
Fractions.
Okay, fractions it is. Would y'all like to see the double distribution method or the box method? Double distribution with the fractions. Okay. So I know that you picked this problem because there's fractions. But guess what you have in your hands and on your computer?
Desmos.
A calculator or Desmos, which is a calculator, that will do this arithmetic for you. So don't be afraid that it's fractions. You're just multiplying the numbers. Okay, so let's take the first thing in the first parentheses and we're going to multiply it to both things over here. You might need to use your calculator for this. Give me 2/3 times 1/3. So we have 2/9 p to what power? What's p times p?
2.
Squared, yeah, squared. Okay, then I do the next one. What is 2/3 p times 5? Again, you have a calculator. What is 2/3 times 5? And give it to me as a fraction. You got a calculator. Don't look at me like I'm crazy. 2/3 times 5. You're still looking at me like I'm crazy. You'd get 10/3, thank you, p. Then we're going to take the next term in the parentheses here. In that first parentheses, what is the next term in that parentheses?
2.
Positive 2, and we're going to multiply that by 1/3 p,
Yes.
which is 2/3 p. You'd ask a calculator.
So one question.
Yeah, I'm listening.
So, hypothetically, never mind. Never mind.
Are you okay? Yeah? Then we just do the last thing. What's 2 times 5? 10. Okay, all I have to do is add my like terms, which is the two things in the center that are lined up. In your Desmos, what is 10/3 plus 2/3?
4.
4. A nice pretty 4.
Ew.
So I know you picked this problem because of the fractions,
Yes.
but you have a calculator. Don't let arithmetic be the reason why you missed this. It's very easy to use these calculators to help you. Additionally, you know if you get this question right or wrong because you can put the question and your final answer into Desmos, and what should the graphs look like if it's correct?
Same.
The same. An equivalent expression creates the same graph. Okay, I'm going to let you keep working, just having one more example of how to do the multiplying. So keep working on your Pokemon, please.
Let's go.